So the next step is to calculate of the median LST value for the kind of urban area, basically for our area of interest. And let's just kind of like think through here for a second. The idea is that what we have right now is the what is this? The average. How did we flatten this? We have the average land surface temperature in summer months in August, July and August between 2020 and 22, correct? Yes. For Baltimore, right? So each pixel represents the kind of the average land surface temperature in these 2 months over 2020, 2021, and 2022. And what we want to know is how much warmer or cooler is the temperature at a pixel compared to the median temperature of all of the pixels in our urban area. Is that fair? So what we want to get is a single value here that tells us the median land surface temperature for all of the pixels in this yellow area, in our urban area. And that's going to allow us to then, in the next couple of steps, calculate the spatial anomalies. How much warmer or cooler is a location compared to the region? Is that fair? So compared to the whole that it is a part of. So that's what we're going for. And I'm going to kind of get down to that part of the script, and I'm going to go over to here, and I'm going to calculate the median LST value for the urban area. And I'm going to paste that into here and then start working on this. So we're going to do something that we've done before. It's a method of an image because that's what we're working with right now, output image. And the median LST, we're going to use reduce regions, and just be careful here. There's a reduce region option, but we're going to go reduce regions. This is going to kick out, I think, just a kind of a number, and this is going to attach the number to each feature in a collection. Is that all right? So we're going to use this because this is kind of the cookie cutter approach, and I'm going to bring it up, just copy the whole thing, and go down here and say, okay, we're going to put into this container the results of this method that we're going to start by saying output image and then dot reduce regions. And then I'm going to treat this, I think, as a dictionary just to keep track of so I'm going to put a curly bracket there, and it's going to get mad at me for a while, but I'm used to things being mad at me temporarily. So I'm going to live with that and just say a collection is going to be the first thing that we need to add. So this is what's the cookie cutter. What feature collection are we going to use to cut up this image and summarize the values within each feature? And so we want to use this thing as our cookie cutter, right? Because we want to say, okay, what is the median land surface temperature value in this entire region? So I think that is just called AOI. And if we go back up to here, you can see, that's it. Our AOI is a feature collection. And the feature collection consists of a single feature, which is lucky. And we'll talk about this in the future, but we're going to just say, all right, step one done. We have our collection is the AOI. Our reducer that we want is going to be the median reducer, right? And we can just go look at that over here. And let's just start doing this. So if I say median, you should see that under reducer, we're going to get the EE reducer median. And there's a bunch of arguments that it could take, but we're just, I think, going to use it without any arguments and just accept the defaults, which I think will be okay for now. The scale, so we've talked about this, I think. The scale is going to be 30 because should be the scale of our input image. The CRS, well, let's just comment this out for a second. and then go up here and say print output image dot projection and see what this is. And let me just call this CRS as the label so I can keep track of it, and hit run. And that should give me something over here. I've got to wait for it. And in the meantime, I'm just going to take this off and start working on this problem a little bit more. But here it's coming. It should be telling us what it is there. And so for the projection, it is EPSG 43216. And I can just copy that and paste it as a string, but I think what I'm going to do is copy this and paste it in there and just say, please grab the CRS and have parentheses here. And I think that is going to, if I print it out there to double check, let's comment this again. I just want to check to make sure that this is going to grab that string and see what we do. And then in the meantime, I'll uncomment this because it's running now, so I don't have to just sit. I can start moving onward. There, it's kind of printing it out. And if I go down here, look, it's trying to print out a string, and there it is. So that should call that, and allow me not to have to update that every time if I should want to reuse this elsewhere. CRS transform and tile scale, I'm just gonna kind of ignore for now. If you do future work if you do more advanced work in Earth Engine, and take another class with me, we'll talk more about how you would use this rather than the scale for calculations. But we're gonna for now we're gonna stick with what we've been doing and move on. It should be fine for our purposes here. This kind of matters more once you start exporting images and wanting to bring them into other platforms. So then we have all of this, and I think that's all we need, right? We should be happy. I've got CRS transform and tile scale commented out. I'm not going to worry about them right now. Let's just go ahead and look at what we made. So put a comma after the label, say this is going to be this, and um, yeah, and then I'm going to go ahead and run this. And it's going to have to wait for a second to see what the result is. Um, and what you should see is down at the base here. So it's taken a while to do this. So what I might start doing is cleaning this up a little bit. Like we don't need to see the histogram anymore, and probably don't need to see this necessarily anymore. So I'm just going to stop printing so many things to the console so that when this runs, it'll just get to what I need a little bit faster. And if I need any of this in the future, I'm going to leave this one alone, but I will do this one. So, okay, but anyway, when we do this, we can see that we got a feature collection that has one feature in it, and in that feature, it has a property that's now called median. So I can kind of cut to the chase a little bit faster if I just say print out the information for the first feature in the collection. There's only one, so that's the one we're after. And then I can say, please get the information that is in the median property. And now if I hit run, it's going to spit out, it's going to hopefully run a little bit quicker because I'm not printing as many intermediary things and the histogram and so forth. It's just we have to wait for the modules to load, but then it should get to the stuff we're after a little bit faster. So I'm going to comment out the projection thing so it doesn't worry about that in the future. And this is there it is, 95.7 4857. So that is our answer. Before we move on, there's one thing I want to mention. So what we did here is we reduced the image. So, right, just to kind of go over this again, we took our output image and we've got our average temperature for summer months in our whole rectangle extent. we then said in our area of interest, this yellow area, give me the median value. And what was kind of lucky is that our area of interest just had a single feature in it. And so it attached the median value to this feature here. Is that fair? We got that extra, right? We got that extra property in the list down here that wasn't up here that told you the median value of this polygon. And this polygon is actually a multi-polygon. So it's going to consider this, this, and this. If we use the inspector and clicked on this object, it is going to tell you that that object down here in the, oh, we don't have that layer yet, so sorry, we can't check this out yet, but the property associated called median that's associated with this polygon is going to be the same as the median for this one. Is that fair? Because all of these, even though they're separate polygons, it's a multi-polygon object, so they're all considered to be one feature. So that is kind of is lucky, and it's because our area of interest is essentially consists of one feature. So what I'm going to warn you about here is, should your collection involve more than one feature in a feature collection, when you use this tool, it's going to give you the reduced value, the median within each feature. Is that fair? So we can talk about this in class tomorrow too. But a good rule of thumb is that if you have an area of interest that consists of more than one feature, but you want to kind of not get the value for each island of the archipelago, but you want to get the value for the archipelago, um, then the easiest way to do this is to kind of say, please grab the union of this. And we can attach it here, even though we just have one feature. And it should give us the same result, right? So if our result was 95.74, etc., and I run this again, it's going to now load the modules, think that through, and then it will start kind of working on our tasks. And our result here should be the same. Is that fair? And so this didn't harm us here. And the value of doing this is, should your feature collection that you are starting with for your area of interest, if this feature collection consists of uh, more than one feature, and you want to get the median value or the summary value for all of the features combined, not each individual feature, you're going to want to use the union to kind of to make that happen. We can talk about this more in class tomorrow if you're confused by this, but there it is. So I'm going to save my script and move on.